You see the screen?
Yeah, yes.
Khaled, I prefer to start because we have a lot. Let the other join us. I will do like introduction and then the other will join us. Okay. So hello everyone. Welcome to session 3 of the swimming pool design course. So far we have completed 2 sessions already, and if we go in a quick recap about the key points that we discussed in the last session, we spoke about how to do the hydraulic calculation, like how to size the circulation pump in terms of flow, TDM, total dynamic head, horsepower, and the kilowatt as well. Also, we spoke about the different types of filters and how to size them. We spoke specifically about how the filtration operation happening in videos, if you remember. See, so we saw the difference between the backwash, rinsing, waste deposition, and the normal filter circulation, and many more details that you can check them in the record that I sent it to you by email. So everything uploaded already in the career learning portal for your reference if you need to go back to see the history. Okay. So in today's session, we are going to continue learning about how to do the sizing calculation for all major items in the swimming pool. Okay. So let's start. I want to make the laser pointer. Okay. So as usual, the agenda here is our main reference to see how we are progressing in this course. So on today's topic, we have the swimming pool circulation system B. Okay, it seems like we are going to see. We'll see today if we can finish all or not. Okay, the next one. Okay. In this slide, I made a summary to review quickly all steps in order to remember and stay linked with all information that we need them to continue in today's session. So now we know how to size a swimming pool pump capable to circulate like all water within like 4 hours, 2 hours, even 1 hour based on the nature of my project as we explained in the last session. And we learned also how to identify this duration time from the code guidelines. So we know how to obtain the pump flow rate, okay, which is calculated according to the volume of the pool and the turnover period. We did also the calculation of pump head, including pressure losses in both suction and discharge pipes, plus filter friction losses, 5 meter, if you remember, heater friction losses, if any, also the inlet residual pressure plus the static pressure, okay? So we need to remember also from the Q, the flow rate, and the H, the head, we can obtain the horsepower, and then we can also obtain the kilowatt. And that's it for the pump. Also, I have provided here a quick summary for the steps of how to size the sand filter, okay? Because we need to ensure the pump and the filter, the capacity of both of them are well matched for efficient operation. It's like a chain, everything relying each other. So we learned the sand filter are normally rated by the tank diameter or ventilation area square meter, which can be easily obtained from the calculated flow rate here. Also, we learned that a larger filtration area improves the efficiency of the process. So oversizing the filter is something good, not bad, if your project allow for this, because this reduce the maintenance requirement and the pressure losses in the entire system, okay? We have also seen the various pieces of equipment, and now we have better knowledge of the general operation of the filtration system. So we know what is the filter position here, you see, and how to do the backwash and the necessity of rinsing after backwash, which have been presented in short videos in the last session, okay? So today, we're going to talk about this backwash here, okay? You see, we are going step by step. So what is the backwash tank? this one. Okay, the backwash tank is essential component of the swimming pool filtration system, designed to temporarily store and manage the water used during filter backwash. When we do backwash here, so this it will like receive all the volume of this backwash. So it serves like intermediate chamber that allows the transition from pressurized backwash coming from this portion, okay, to the gravity drainage system, okay, because normally the swimming pool designers, most of them, they are not considering such solution. They are just discharging to nowhere and telling by others, which means someone like WSCB, he has to accommodate this one. They are relying on us, we are relying on them, and we keep relying on each other until we reach to a point it's too late. We discover this has not been considered. So the best solution, this backwash tank, it should be considered by the swimming pool designers, and it has to be properly sized and calculated, as we are going to see now. So this tank help to control the discharge of the backwash flow to avoid overwhelming the main drainage system, okay, and also it could be used to enable water recycling. This in some cases it could be reused for like in green projects, like LEED projects. It could be reused or recycling by reintroducing the water back into the pool in somehow, or balancing tank, which require a special arrangement in the backwash process that we can cover when we discuss the overflow circulation system. So remember, we're still in the skimmer. We are still in the skimmer. Let's go back. So this, we are talking about skimmer system. We have overflow system is going to be discussed after finishing this one. So going back again to this one. So this is the backwash in general. As you see here, this is the simple circuit. And usually in the filtration mode, the water go to the pool. In case of backwash, it goes like that. And we can make provision just in case if we can connect it directly to the drainage network. Okay. So there are some examples of different brands, but to be honest, it is not common to find like vendor for such type of things, because it is not also common to be considered in the design. So I searched on the internet to find some vendors for this one. I found very minimal. Those only are available for this one. So as you see here, very simple design. It is just a tank, plastic tank, or PPR, I don't know this material, okay? Just a regular tank, and they provide two levels of control, two valves like that, okay? And I'm going to, okay, let me explain here. So this, if there is backwash, I will show in video how the backwash happening. If there is backwash, so the backwash coming with dirt and mud or dust or whatever, dirty water coming, okay, in turbulence flow, it keep going here, okay, and then after finishing this water, we can keep it like long time, maybe half day or 1 day. Then the sedimentation of the solids like debris and the stuff will go down here, okay, and the above portion here, the top portion here, it will be like clear, clean water. It could be reused. Actually, the amount of backwash volume is water volume is too much. So this is actually good solution, smart solution to reuse this water instead of like wasting too much water every time we do backwash, and it could be recycled. But we need special arrangement for this process, as I just said, and I'm going to cover it later if needed in the overflow, because we need to connect it by gravity to back. Okay, and sorry, I will go back here. If you noticed here, I make X because I saw one design before someone did it, which is actually fatal mistake, connected back to this line. This actually is supposed to be by gravity, not to be connected directly to pressurized line like that. Otherwise, it will introduce air and it will make maybe problem. It makes the pump run dry if once this one finished here. Okay, so it has to go by gravity. This, it needs a special arrangement to locate the tank in a level higher than the tie-in connection, whether connected to the balance tank or return it back to the pool, as I'm going to show you in this video. Okay, so this video shows how to use the backwash tank to save the water, because you know, the amount of volume, the amount of water is too much. It could be reused, because around 90% of the volume of backwash water, it can be reused again. No point to waste it if there is solution like that. You see, the water is coming dirty like that. They keep it like 24 hour or half day until it is settled down, so the top part will be clean and the bottom part will be the dirty one that we can take it. You see, it's like clean water above, and then the sludge down, it could be removed separately. It is just simulation, but in reality, we will not put the tank like that exposed to the public. Okay, so that's it. So the question, any questions? Any? No. Okay. How to size backwash tank? Okay, to size the backwash tank, we need to know that this tank should be large enough to accommodate the total backwash volume. So we have to know what is the volume of water that we need in the backwash process. So designing a backwash tank, or we can call it a gravity transition tank, as I explained, required careful consideration of flow rates coming from the pump, the retention time that we need it if we are going to reuse this one, this water, and the proper flow control, as I just explained in the valves and levels and the stuff. So to calculate it, we can use this equation like that, the backwash flow rate, which is the same pump flow rate. We are using the same pump. We are not designing or assigning a special pump for this one. The same pump doing the circulation and the normal operation of filtration, we use it for backwash. So the flow rate coming from this pump times the backwash duration. Okay, how long it takes, maybe 3 minutes, 4 minutes, times the retention factor. You can call it also safety factor. So this, the total volume of the tank. So the retention time, actually, this you can call it the rinsing time. If you remember last session, we said after backwash we have to do rinsing. So the rinsing, it's supposed to go to the waste, right? So we can take it to the backwash tank with the backwash flow, and both of them we can reuse them again if possible or if needed. So the tank should be 1.2 times the calculated backwash volume for safety. Okay. Okay, so our famous example, this example continues us from last session. The same pool, 10 meter, 15 meter, okay? So the given data that we have, the pump, if you remember, we calculated the pump last time, it was 10.5 liter per second and 2 pumps. So the total around 21, something like that. The filter diameter that we calculated, it was 0.9 and the total number 3. The total backwash rate, 40 meter cube per hour per square meter of filter area, okay, which is the same flow rate. So the backwash duration 5 minutes, okay, and the retention factor 1.2. All of this given data, it can help me to calculate the volume. So the tank volume, it will be like we multiply this and this and this, it gives me the total tank volume. This is the total tank volume. So now we calculate it. Okay. Okay. Now then, the next one, the drain points. Okay. We'll speak here about the skimmers first. Skimmers and even gutters or overflow channels that we are going to discuss in the next session. It shall be provided, okay, here. It shall be provided to maintain uniform skimming action on the water surface. We discussed this one in the first session, if you remember, by removing the dirt like hair and the other floating objects in the surface here of this water to be removed by the skimmer. So to ensure efficient surface skimming and debris removals, the floating debris here, skimmers must be properly sized based on the pool dimensions, the flow rate, and even the placement, the location of the skimmers. For instance, pools with strong wind conditions, if we have like windy weather, like in Europe, usually they have too much wind. So skimmers should be placed strategically on the downwind side of the wind in order to collect the floating debris. So if the wind going to this direction, the skimmer should be in the receiving position to collect or making skim to all floating items in the pool surface, in the water surface. Okay. So as we know, the skimmer. Okay. If I go back, the skimmer. Okay, I want to go. Okay, as we know here, the skimmer connected directly to the pump, unlike the overflow. I explained in the first session. The overflow, they have intermediate balancing tank in between. So here the skimmer connected directly to the pump. Okay, the section of the pump. So anti-siphon loop, this one, or any similar solution shall be provided at the skimmer, this skimmer body, to prevent suction of air into the circulation system. So we have the pool water coming here through the basket, and it's supposed to go to the pump here. In case of, for example, this level of water go down, or they have like debris like leaves or papers or something clogging this one, this small piece, which is called skimmer diverter plate, the one that we see in the video, help to ensure proper circulation and protect the pumps from running dry if the skimmer basket get clogged, or if the water level drops below the skimmer opening here. Okay, so in this case, it will divert directly to take the suction from the pool. Here we are in safe level because the water definitely covering this portion. Okay, we need to remember this connection. You call it safety or balancing or equalizer, whatever. This one, it will be used also in the vacuum. I'm going to discuss in the upcoming slide. So this one would be used for vacuuming, and I need you to remember this one. Okay, how to size the number of skimmers? Okay, number of skimmers, we can calculate it from this equation, the total pool surface area divided by the coverage of each skimmer. So we have here three criteria we need to consider when we do sizing for the skimmers. We need to know how many skimmers we need for my pool. Okay, so the surface coverage for each skimmer, we consider it the maximum 45 square meter. So could be less. To be on safe side, make it 30, 35. It depends. Okay, the position also, the placement spacing between the skimmers, it has to be within this range, 4.5 to 7.5 along the pool perimeter. So this is the second criteria. The third criteria, the flow rate. Okay, and this flow rate, it vary from model to another, but the range from 5 to 7.5 meter cube per hour. Okay, and the last thing, we need to consider the total flow, because we have the pump giving 100% flow. This flow, it will be directed to the skimmer, and it will be directed also to the main drain down. So we have to size the skimmer in a balanced way to ensure some of the flow will be taken by the main drain. So now when we consider the skimmer in terms of number of skimmer, we consider 60% only from the flow, the total flow coming from the pump, going through skimmer, and the remaining it will go through the main drain. Okay, so here we have some recommendation we can consider to distribute the skimmer evenly, and this is like logic things that you can do it without guidance actually. So how to size the skimmers in our famous example here, the same pool, 10 meter, 15 meter. So as you see here, the given data, the perimeter, because we have three criteria as I told you before, the coverage 45 square meter, okay, maximum, and the spacing should be something like 6 meter, and the flow rate and 60%. So with this information, the total flow rate we know from our example, the pump calculated 75.6 meter cube per hour, or 21 liter per second in different unit. So the skimmer covering 60%, which means 45.4. So this is the main given data that we are using to calculate the skimmer. So how we do this? First, based on the first criteria, service coverage. So we have 4 skimmer. If we calculate it based on the service coverage, based on the spacing, okay, we'll need from 7 to 11. Based on the flow rate, 60%, it will need like from 6 to 9. So we have 3 inputs now, or 3 results. So we can choose the best one that covering or satisfying all criteria. Okay. So selection that I made it here, 8 skimmers. This meets all necessary design criteria. As you see here, based on the service coverage, it is less than 45 square meter. Okay, it's like that, 18. Based on the spacing, it is within the range, 6.25. Based on the flow rate, 5.6, which is within the range as you see here. So it's satisfying all criteria. In terms of the distribution, as you see here, I make it evenly around the pool. And if you have like irregular shape or something, you can consider this one, and wind also direction. So regarding to positioning this one, you have to consider many things like the shape, okay, the architecture, design, wind, and so on. So I make it evenly like that around the perimeter of the pool. Okay. So we finished the skimmers. We are doing good so far. The second one, the vacuum points. You see these vacuum points connected also to the filter of pump. Anyone having questions? Okay. Vacuum points. Okay. Vacuuming in pools is essential part of pool maintenance. Okay, to remove debris and algae from the pool floor. I'm talking about the pool floor now. It ensures also water clarity, hygiene, and the overall efficiency of the filtration system. So there are different methods for vacuuming the pool, depending on the pool type and its filtration system and the nature of the project itself. So the first type we have here is manual vacuuming, which is the most common one. In this type, we use a vacuum head, okay, attached to telescopic pool, and a vacuum hose, okay, like this one in the picture, connected to the skimmer. You remember when I told you, remember this in the skimmer, or dedicated suction port like this one, okay. And I will show you how to design dedicated port like that. If it is in a skimmer, it is in a skimmer. If it is not in skimmer, I will show you how to size it and how to design it now. So how to do the vacuum, how to do this? First, we need to assemble the vacuum system by attach the vacuum head, this one, to the telescopic pool, and connect one end of the hose to the vacuum head, this head, okay, and the other to the skimmer or the vacuum board, like here. So two sides it should be connected to the board and this head, okay. Um, then we need to prime the hose because it is not full with water, it is having too much air. We will submerge the hose to fill it with water and remove all air bubbles to the to maintain the suction. Then start vacuuming. So vacuuming happening like that. Move the vacuum head slowly across the pool floor to avoid raising the debris. Okay, because the debris settled in the floor. If you are moving so fast, the debris will go up, which is not required. So we have to move it slowly, and overlap buses to ensure complete cleaning. Okay, so just yeah. Okay. So we need to know the vacuum, if the vacuum connected to the skimmer, if this is a skimmer not port, we need to ensure the pump runs at optimal pressure. If you remember in the backwash, I told you that there is optimal pressure. We can find it in the gauge, and over time, when the filter starts to get clogged, this pressure raising, and it give until it reached to level, give indication the backwash is it has to happen. Okay, and this one it will go back to the pump, and then the back after after going to the filter, sorry, and going back to the filtration system, and over time the filter, this debris will be stuck in the filter. So maybe we need to do backwash after finishing the vacuuming here. Okay. Okay, and this is the second type of vacuum that we have here, is called self-cleaning system, self-cleaning pool system. So this system uses pop-up, you see here, pop-up jets to push debris toward the main drain, which is located here, okay? Then goes through pipes to containment. Here it's called canister, or can, like collection, like strainer here. So this system rely on automatic water valve. You see this one, number 6, okay? Automatic water valve to control the water flow and ensuring efficient cleaning and enhancing the circulation in the system. Okay, as you can see in the video, in the next slide, there is video for this. So we need to know that this system actually is good for large debris only, because over time the accumulated sticky fine dirt here require manual brushing, which return us back to the manual vacuum system that I explained in the previous slide. So this system not common to be used, as it is like complicate the pool piping system as well. Okay, but I just wanted to show you all systems, even if it is not common, in order to be familiar with everything, even if it is not used like this one. But in some cases, you can find it in ultra luxury hotel or like high level projects. Okay, so this is one of good brands that provides such type of self-cleaning system. As you see here, you see the leaves in the bottom, the heavy leaves. The jets keep pushing, you know, one after one. It go up and push and down until it reach here, and then through the main drain, it will be collected through this strainer or canister, they call it, and then it can be removed manually from time to time. So it's fully automated. Even in the walls, you see the jets pop up and push, pop up and push until reach to the drain. You see in the walls, even if they have stairs, if it is a spa or something like that, and they keep pushing, pushing until reach to the main drain located in the lowest point here, as you see here. Okay. Third type of vacuum that we have here is a robotic pool cleaner. So this system is like a wireless machine, as you see, that moves around your swimming pool on its own to clean dirt, debris, and algae. It runs in a rechargeable battery, so you don't have to plug it in with electrical power while it is working. It work alone like that. So how it works, this one, just put it in the pool, as you can see in this video, drop it in, and then it moves on its own, because it has wheels or tracks to move around the pool. So it go everywhere to clean floors and walls. Also, it use brushes and suction to scrub and to collect dirt. Then it keeps filtering the water, trap the leaves that you see, and tiny objects in its built-in filter, and finally stops when it is done. Okay. Some models have a smarter technology actually to map the pool and clean efficiently, but this is one of the famous one, the robotic vacuuming. No questions. So how to size the number of vacuums? Ramos. Yes, Ramos, tell me.
Yeah. Which the vacuum robotics or the conventional vacuum, which one is at your point of view? Which one is
The manual,
convenient or
the manual
manual?
one. This is the most traditional and the common everywhere.
Mm.
But also you can because okay, if your pool, it depends on the nature of your project. If your pool external pool exposed to sky and surrounded with landscape or jungle like in Australia or something like that, so the amount of debris like leaves and stuff, it will be too much and it will be like headache for the operator every day to clean it. So you can use the robotic one or the automatic system. Actually, the automatic system more complicated. You can use the robotic one for daily cleaning, and over time, when the sticky, the dust and the stuff, the heavy dust go down and they stick in the floor. So you can use the vacuum, the manual vacuum to keep pushing, brushing, and scrub all dirt in the bowl. So that's why the traditional one, the manual vacuum, it is needed actually, cannot be avoided. And also it could be used in parallel with the manual vacuum, we can use the robotic. And I'm showing example for how to size this one, both the robotic and the manual vacuum. Okay. Okay, how to size the number of vacuum? I'm talking here about the manual because this is the one that needs a specific design. If it's connected to the skimmer, خلاص, if we have a skimmer type. If we don't have a skimmer like overflow and we have to provide vacuum port, we have to size it properly and calculate it. So the number of vacuums, it should be calculated based on the surface area and the flow rate for everyone of for every single vacuum port times the operating hours. Okay. So if I'm cleaning in 1 hour, 2 hours, 3 hours, as more hours we have, as more vacuums we need. Okay. Sorry, as less. Okay, because you need you can take the hose from vacuum point to another. So if you have time, so the vacuum points it could be less. Example here, a robotic vacuum cleans 100% square meter per hour. This is the criteria that we are using to size the robotic vacuum. If we have manual vacuum, okay, the manual vacuum cover from 40 to 50 square meter per hour, every single port covering within this range. Okay, and the single vacuum typically in terms of flow rate, it takes from 8 to 12 square meter per hour. This table, it is like rough estimation. You can use this table as a rough estimation in order to calculate the or to size the vacuum, the number of vacuum. So if we talk about the manual for this small area pool, if we have pool less than 200 square meter, one vacuum is enough. Medium like this and so on. The same for robotic. One machine here, two machines, three machine, and so on. So you can calculate it from here or directly use this table as a rough estimation for this one. Okay. Uh, Here we have example, the same example. Okay, the same pool. We are calculating the vacuum for this pool. So we have total flow rate, this one, and I forget to tell you the hose length, the typical hose length 15 meter. This is one of the things that you should consider when you size the vacuum. So the hose, it will cover certain circle or certain area. So 15 meter, the typical or the maximum length of the hose. It could be less, okay, but the average 15, and it could be more also. The average 15. So consider this one. Typical length of the hose around 15 meter. Okay. Okay. So the manual vacuum typically cover from 40 to 50 square meter. Robotic cover 100 square meter for every hour. So by using this assumption, sorry. So by using this assumption, okay, So we will assume 50 square meter per hour for manual vacuum. So the number of vacuum can be calculated like that. This divided by this times 1 hour, okay, it will give me 3. If we have more hours, as I said, let's make it 2 hours, it will give me 1.5, rounded up to 2 vacuum, okay? So if you calculate it based on 1 hour cleaning, we have big number. If we make it more hour, it will become less number, okay? So I will take this one, 2 vacuum, okay, instead of 3, because it is not that big. It is like medium pool. 2 vacuum is enough. If you remember, I told you the hose is 15 meter. So if this 15 meter, 1 inch, okay. In the middle here, we have 7.5, 7.5. So your hose will be enough to cover and overlap with the other side. Okay, so you will ensure the entire pool is reachable. Okay. After that, we have, after the vacuum, we have the main drain. How to calculate the main drain? Okay. So main drains are the main suction outlet located at the deepest part of the swimming pool. They play a crucial role actually in water circulation and debris removals and preventing stagnations. Okay, stagnation in the water here, because main drains help extract water from the bottom, ensuring uniform mixing and proper filtration happening in the pool. So the purpose of main drains is improve the water circulation by pulling water from the deep end, facilitate pool draining for maintenance and cleaning, and also maintaining uniform temperature, because this drain enhances the hot water distribution and circulation throughout the pool. And also applicable for the chemical, okay, it enhances the chemical distribution throughout the pool. So keep in mind, the main drain shall be designed in a way prevent vortex formation. This is the main thing that we need to consider when we design the main drain. We have to prevent vortex formation and also hazardous suction forces, because the main drain usually the flow happening here, it is too much, and maybe the velocity will be higher than required, and this will cause like vortex, and because this in the most deep point, maybe the people will be or the children exposed to be sucked by the this one through the vortex and stuff like that. So the cover must be secured or securely fixed and heavy enough to prevent swimmers from accidentally or even intentionally remove it. This one, it should not be removed, this cover at all, and there are different models of this one, and this actually key safety measure to prevent entrapment accident. Okay, also the openings here, okay, and the drain cover should not exceed 12 mm, like 1 centimeter, 1.2 centimeter, to prevent fingers or toes from getting stuck here. It should be small, 12 mm. So the cover material must be anti-vortex type, the design of this one. There are different design, and shall be designed to reduce vortex formation, ensuring smooth water flow while preventing hazardous suction effects. So we need to consider also some design criterias, okay, like what? If the pool width exceed 9 meter, multiple main drain outlet must be provided, okay. So the drain outlet spacing to be like that. The main drain must be spaced minimum 2.5 meter with no more than 6 meters. Yeah, I'm talking about 2.5 to 6 meter apart, and they should be placed no more than 3 meter from the side walls around the pool to avoid dead zones happening in my design. Also, in terms of water velocity limitation, the maximum water velocity at the drain should not exceed 0.5 meter per second. It has to be very slow to avoid the vortex. So this prevents vortex formation which can lead to air entrapment and hazardous suction forces. So we need to make it as slow as possible. Okay, no question. Okay, so the example. How to size the number of main drains. Our example, okay. So the total flow rate, as we know, 75 meter cube per hour. So the solution is number of drains. It will be 3 based on the flow rate divided by flow capacity per drain cover. Okay. Total pool we have 75.6 meter cube per hour. If we selected, this is like actual model, 200 mm astral, 100 mm, 200 mm main drain. So the capacity of this one, I found it in the catalog, around 30 meter cube per hour per drain. I was planning actually to show you the website when I prepared this material, but I forget. But there is model like that. If you search it in Google, you can find it. So the capacity of this one, 30 cubic meter per hour. So based on this, the required number is 3 drains. I put it here because it has to be located in the lowest point. I assumed this is like made example. And I assumed the deepest point here. So this maintain the all criteria, design criteria that I explained to you. Okay, 3 meter, 2.5 to 6 distance, and so on. Okay. Okay. And then after that, water inlet. What is the time now? Okay, I still have time. The water inlet design. So how to size the number of water inlets. You know, the pool water inlets are used to discharge water inside the pool at the first filling when we fill the pool, or during the day for the filtration. It keeps circulating. So we have to ensure proper water inlet distribution in the design by distribute the inlets evenly across the pool to ensure uniform circulation, same like what we did in the skimmer, and position this water inlet opposite to the skimmer to optimize the water movement. Do not put it beside the skimmer. Okay, try to make it in the opposite side as much as possible. And also consider floor inlets for better circulation. If we have deep pool, if the pool too much deep, we have big distance down. So to avoid the water keep short circuit in the surface or in the high level, we have to provide some inlets from the bottom. Okay. Okay, this adjustable, you see. The good thing about this one, it needs to be the wall inlet. It could be adjustable to increase or decrease the flow. It can go 360-degree in any direction that we need. And the testing and the commissioning could be adjusted as wish. Okay. So how to size the number of water inlets? First, we need to select the type of this inlet and the flow rate. Based on the type, the flow rate will be obtained. As you see here in this schedule, if it is wall inlet adjustable, it will be from 5 to 10 cubic meter per hour. If it is floor inlet, it will be like that. If it is channel, but this is not common at all. So if it is channel, it will be like that. Based on the type of the water inlet, okay, we can identify the flow rate required for my calculation. So how to calculate the number of inlet? The same like skimmer. We have the flow, we have the total flow, and we have the individual flow for every single inlet. So we can obtain the total number of the inlets. So our example here, okay, we have the flow, we have everything. So the solution like that. I assume the typical wall inlet, as you see here, between 5 to 10, I assumed 8 meter cube per hour. Okay. And then step 2, we can calculate the number. It became like 10. I rounded up to 10. So we distributed like that. Then after that, piping. Okay. So we need to know that as well sized piping system reduce energy consumption. and also minimize the maintenance and ensure proper pool circulation. So by following the recommended velocity limits, you can design an efficient and reliable swimming pool piping system. So as you see here, to ensure the flow without excessive friction losses, we have to follow this criteria. The suction pipe, the main thing, the velocity. In order to size the diameter of any pipe, the famous equation, the flow equal velocity times the cross section area. So if we know the velocity and we know the flow, definitely we can know the diameter. So the recommended velocities based on the position of this pipe, if it is before the bump, after the bump, if it is gravity, so we can calculate accordingly. So the suction pipe before the bump, it has to be like 1.5 meter per second, but downstream the bump 2 or 2.5 meter per second could be higher speed. For the gravity, as I told you, if it is membrane 0.5, it is something else, it could reach to 1 meter per second. And I'm going to show you how it will be sized every individual one. So the selected pipe must be accommodate the required flow rate while staying within this velocity limit. The velocity is the main criteria to calculate the diameter. So this is the equation, and we know from area we can obtain the diameter like that. We can see here in the example. Before the example, these tables show maximum flow rates for each pipe diameter with 1 meter per second, okay, 1.5 meter per second, 2 meter per second, 2.5 meter per second, and so on. And I need you to know that this table for rough sizing only, because the accurate sizing shall be done based on the actual pipe diameter and the pressure drop in this actual pipe material and the allowable pressure drop in this material, and so on. So there are many other factors could be considered in order to calculate the diameter precisely in accurate way. Okay, so we need this needs to be done if we want to make it accurately in hydraulic calculation. That needs to be done usually by the contractor as a part from his verification calculation process. But ultimately, believe me, the difference is very minimal. It is not that big to waste your time. So in design, you can do it based on this, okay, the rough estimation, and then the contractor, he can make the hydraulic calculation as part from his shop drawing and the calculation verification for this one. Okay, so how to size piping system. Let's talk first about the water inlets, since it is the last one that we finished in terms of number of sizing. Okay, so if you remember in our example, when we calculated the water inlet total number, we found it 10. Okay, 10 number of water inlets. So yes, 10 here. So here, as you see here, the total flow rate equal 21 liter per second or 75 meter cube per hour. And the typical water inlet, we know this one, 8 cubic meter per hour. And this water inlet downstream the pump, okay, the pump give this inlet. So which means the applicable velocity between 2.5 meter per second. So if we take it 2 meter per second, by the way, you need always to reduce the velocity. But also consider when you increase the velocity, the diameter will be increased. So it depends on the project. If you have like Olympic or big swimming pool, as low velocity you have, as bigger diameter you provide, and it might cause coordination issues with other things. So it depends on your vision while you are doing the design. You know the limitation, and based on your condition, you can select what suit your project. So the pressure pipes after the pump, this is our case because we are talking about water inlet here. The recommended velocity like that, 2 to 2.5 meter per second. So if we apply this equation, okay, and we select this velocity, 2 meter per second, you can size every single piece of pipe based on the flow rate running in this pipe. So we'll take it like that. Every single inlet in order to feed 2.2 liter per second, okay, with this velocity, it will give you it will require 1.5 inch pipe. Okay, so if we have two If I'm feeding 2 inlets of this, I need 2 inch. If I have 3, okay, so I have 2.5 inch and so on. So we'll see like that. You see the same table here. I minimize it for easy reference to this one. So again here, the flow rate of the pump, we know 21 liter per second. The velocity 2 meters, so 6 inches applicable here. This one feeding the entire boat, the total number of water in it, which is 10, right? So we have 10 here, 6 inch, okay? And then we have this flow in this direction, feeding 1, 2, 3, 4, 5. So this one, 5, which means 5 here, which means 3 inch actually. Okay. Sorry. 5, which means 4 inch. Okay. This one feeding 5. Here feeding 4, 3 inch. Here feeding 3, like that, and so on. So based on the number of inlets that you feed, you can obtain the flow, you can obtain the diameter according to the recommended velocity for this condition. Okay. And the same for the other side. With this concept, you can calculate the pipe size for every individual part. For the skimmers, the same concept based on the recommended velocity, because this is like the suction side of the pump, we have less velocity. So the recommended velocity 1.5, I will take it 1 meter per second because I need to be more safe. So based on this one, you can calculate based on the flow rate for each individual skimmer. So we know every individual skimmer will take how much flow rate per skimmer for 5.67 meter cube per hour. So this one will need 1.5 inch for one skimmer. For 2 skimmer, 2.5, for 3 skimmer, and so on. Okay, like that. We have here the return, the main return, 6 inch, because the main return covering how many? 6, 7, 8. So covering 8, okay, with 1 meter per second velocity. So 8, we need around 6 inch, from 5 to 6, because 5 is not standard, so we'll make it 6. And then we have here 1, 2, 3, 4, 4, which means, okay, 100 mm, 4 inch, okay, and so on. 3, we need 3 inch, 2, we need, and 1, it will need like 2 inch, and so on. Okay, that's it. Thank you. We finish early, 5 minutes to 7 minutes. Okay, so any questions? You still with me? No questions? Guys, you are here,
Khalid,
available?
we need to do practically, then we will understand, I think.
Yeah, we'll do
Now,
practical in the last section.
yeah,
But
but now,
the idea become slowly clear than previous session, right?
a lot
Or
of things to be taken care, I think. So we need to look into it one more time, and then we will see.
okay, thank you, Girish, for your input. We'll do it together. We'll do one more project. Okay, we'll repeat all of them again together, and you will do alone one project, and you will see when you do it yourself if it is difficult or not. And I'm available if you have any question. Okay, thank you,
Okay,
everyone.
Khalid. Thank
And
you. Thank you,
I
Khalid.
want to say something before leaving. I will cancel the next session because I have something else to do, and we will do it after 2 weeks. So the next Thursday it will be cancelled. Okay.
Okay, Khalid.
Yeah.
Thank you.
Yeah.
Bye.
Thank you, Khalid.
Thank you.
And thank you. Bye bye. And so think